This video talks about raising a complex number in polar form to an exponent. Since raising a number to a positive integer power is a repeated application of our product theorem, we can use product theorem to develop what's called DeMoivre's theorem. DeMoivre was a famous mathematician that developed this theorem. So if we have a complex number in polar form, call it r times cosine theta plus I sine of theta, and we raise it to some power, what we do is take our r value and raise it to that power, and then we multiply each of our arguments by that power as well. And then we have our compact form as always with the CIS notation. So raising r to that power, multiplying our argument by the power as well. Let's find 2 cosine of 120 degrees plus I sine of 120 degrees to the third, and we'll express our answer in rectangular form. We start by taking our r value and raising it to the exponent. That'll be 2 to the third. And then we're going to multiply each of our arguments by that exponent as well. So this becomes cosine of 120 degrees times 3 plus I times sine of 120 times 3. We'll do some cleanup there on the inside and on the outside. 2 to the third is 8. 120 degrees times 3 is 360 degrees. So there's our answer in polar form, but we want to get it in rectangular form, so we'll distribute the 8. And then find our 2 exact trig values. Cosine of 360 degrees, well, 360 is the same as 0 degrees, so either way you want to think about it. Cosine of 360 degrees is 1, and sine of 360 degrees is 0. So 8 times 1 is 8, but 8i times 0 is 0. We get an answer of just 8. Let's try another one. We want to find 2 square root of 2 minus 2i square root of 2 raised to the 6th, and we'll write our answer in rectangular form. Well, you'll notice that our given number is in rectangular form, and our theorem only works when we are in polar form. So the first thing we need to do is convert this 2 square root of 2 minus 2i square root of 2 to polar form. We'll find the r value using the fact that r is equal to the square root of x squared plus y squared. Remember, our complex number is x plus yi. So we'll have r equals the square root of 2 square root of 2 squared plus a negative 2 square root of 2 squared. We'll square both the 2 and the square root, so this is 4 times 2 plus 4 times 2. So we got 8 plus 8, r equals the square root of 16, which is equal to 4. We also need to get our theta value using the fact that tangent of theta is equal to y over x. So tangent of theta is going to be negative 2 square root of 2 over 2 square root of 2. So tangent of theta is equal to negative 1, making theta equal to tan inverse of negative 1. We know there are two options where tangent is equal to negative 1. We want to look at which quadrant our complex number is in if we were to graph it, and then that'll tell you which of the two theta values we want. Now, since x is positive and y is negative, we're somewhere in quadrant 4. So the place in quadrant 4 where tangent is equal to negative 1 happens at 315 degrees. So theta is going to be equal to 315 degrees. Well, now that we have those two things, we can rewrite our answer in polar form. This becomes 4 times cosine of 315 degrees plus I sine of 315 degrees. And then all of this raised to the 6th power. Now we're ready to apply the theorem. And our theorem tells us to take our R value and raise it to our power. So that'll be 4 to the 6th times, and we're going to multiply our argument by that 6. So 315 degrees times 6 plus I times sine of 315 degrees times 6. Doing a little cleanup here, 4 to the 6th power, just pop it in your calculator. That's 4,096. And then 315 degrees times 6 gives us 1,890 degrees. We want to write our answer in rectangular form, so we'll distribute the 4,096. And now we need our two exact trig values. Well, I'm not super familiar with what cosine of 1,890 is. So we'll want to get a coterminal angle that is between 0 and 360 so we can actually find these values. Remember, to find coterminal angles, you just subtract 360 over and over and over and over until we get a number somewhere between 0 and 360. And if you do that over and over again, we will eventually land at 90 degrees. So this becomes 4,096 times cosine of 90 degrees plus 4,096i times sine of 90 degrees. And now these are some trig values we know. Cosine of 90 degrees, that's going to be 0. And then sine of 90 degrees is 1. So 4,096 times 0 is just 0. And then 4,096i times 1, we get a final answer of 4,096i.